Okay, it's there now.
Ok. Voy a comenzar, ¿de acuerdo?
De acuerdo, Ana, muchas gracias.
Good morning. Good morning. The Engineering School of Universidad de Antioquia welcomes you and would like to thank you for your presence in this room for witnesses the defense of the thesis of Fabian Andres Castaño Usuga, a student of the Doctor of Electronic Engineering and Computer Science, Universidad de Antioquia, the Engineering School, and the Research and Graduate Programs Office, taking into consideration that the student above has complied with all requirements set forth in the general and specific rules for the Engineering School Graduate Program, have we organized a public ceremony for the presentation of a thesis entitled Motion Artifacts Reduction in Electrocardiographic, photoplethysmographic, and non-invasive blood pressure signals through multi-channel signal processing techniques in such a way that the student can be awarded a PhD in electronic engineering and computer science. This thesis has been directed by Professor Mauricio Hernández Valdivieso from Universidad de Antioquia and co-directed by Professor Georges Romero from Laboratory of Analysis and Architecture of Systems in France. Presentation of jury. The ceremony for the defense of the thesis has been attended by the following judges: Professor Rodrigo Gómez Martínez from the Universidad de los Andes, Profesor Robinson Alberto Torres Villa from the Escuela de Ingeniería de Antioquia, Professor Christian Diesel from Justus Liebig University. Now, let's welcome the student who will present his doctoral thesis. The student is advised that he is given 50 minutes to perform his presentation. Please, Fabian.
Thank you for the introduction, Professor Anna. I hope you can see my screen. Now, I will begin with the outline of this presentation. This presentation involves the introduction and problem statement, the hypothesis and objectives. After that, I will present the general methodology, specific methodology and results. And finally, I will conclude with the main conclusions, future work, and achievements that we found with the development of this thesis. Let me begin with the introduction, problem statement, and hypothesis. Then, since some years ago, the World Health Organization has been studying the life expectancy trends in the general population and found that for the year 2050, this statistic increased until the 79 years in the population. That sounds a little bit great, but the problem is it comes with increasing in the prevalence of the illnesses like cardiovascular diseases, and two, it comes with increasing of the deaths per year that now is near to 17 million deaths per year, and the costs of hospitalization are around 800 billion euros per year too. Also, other statistic that is not great is that for every 100,000 inhabitants in the world, there is just 33 doctors, 84 nurses, and 24 beds in hospitalization rooms. And the overcrowding increased the mortality around 10% when you delay the attention 2 hours in average. To solve this problem, some scientists propose some methodologies to improve the attention. Some of them are related with the use of wearable devices, that is around 75% now, and the use of methodologies of care in home, like telemedicine or home care. Combining those methodologies, you can to provide a home health care attention that allows to the medical to know the information of the patient remotely. The problem with this is that some of the devices that are developed for this purpose are not able now to obtain a good information to make the monitoring or the diagnosis of the patient. It's because some of the more important sources of noise are related with the motion artifacts that are produced for the motion of the patient. As I mentioned before, one of the sources is the motion artifact, but it's not the only one. The other source are the power line interference, the baseline wander, but one of the most important, I remark, is the motion artifacts. The problem with this is that when you are at rest, you can to measure the information of the patient with a good results. You can measure, for example, the electrocardiography, photoplethysmography, and non-invasive blood pressure with a good results. But when you try to measure the information, when the patient or the person are making movements, the information is contaminated by motion artifacts, and this contamination don't allow to obtain a good result because can to lead for my misdiagnosis in the information. For this reason, the information obtained with these devices is not useful for medical monitoring or medical diagnosis. This problem has been addressed in some different ways. One of them is the hardware approximation that includes the modification in the hardware of acquisition and the implementation of new sensors, for example, new electrodes to measure the electrocardiography or the photoplethysmography. And the other way is related with the software, specifically with the digital signal processing methodology. One of the lines is related with adaptive filters, other is related with the computational intelligence, and finally the signal decomposition. But those methodologies continue still without a good result. For this reason, we propose the following hypothesis. The change in the hardware for the acquisition of vital signs, the redundant and simultaneous acquisition of electrocardiography, photoplethysmography, and non-invasive blood pressure, and movement of the person, and also the implementation of multi-channel signal processing techniques could significantly reduce the motion artifacts in ambulatory monitoring. Now I will present the objectives of this thesis and the general methodology. To try to solve the hypothesis that we propose, the main objective of this test of this work is develop and validate a technique for motion artifact reduction in electrocardiography, photoplethysmography, and non-invasive blood pressure signals of healthy people with modification in acquisition hardware and multi-channel signal processing techniques for ambulatory vital signs monitoring. The specific objectives of this work are: the first, develop a systematic review of processing techniques focused in the reduction of motion artifacts in electrocardiography, photoplethysmography, and non-invasive blood pressure signals. The second one is model the effect of motion artifacts over electrocardiography, photoplethysmography, and non-invasive blood pressure signals in healthy subjects performing controlled physical activity. The third objective is design and evaluate modification to the portable vital sign monitor development EGB, and in order to reduce the motion artifacts in electrocardiography, photoplethysmography, and non-invasive blood pressure signals. And the fourth objective is develop and evaluate the performance of a multi-channel signal processing technique to reduce motion artifacts in electrocardiography, photoplethysmography, and non-invasive blood pressure signals in healthy subjects. The methodology that we propose, it looks very complex now, but can be to resume in 5 specific tasks that solve the 4 specific objectives. The first task is related with the ethics committee endorsement requests and database registration. The second task is related with the characterization of motion artifacts. The task number 3 is the model of the contamination effect of motion artifacts. The task number 4 is the evaluation of modification in the hardware of acquisition. And the task number 5 is the multi-channel signal processing technique for motion artifact reduction. Now, let me show you the specific methodology and results. Then I will begin presenting the results for the task number 1, related with the ethics committee endorsement requires and database registration. For this purpose, we propose a protocol of measurement of the signals that involves 14 subjects at least, but including some inclusion and exclusion criteria to reduce the side effects into the registration of the signals. This protocol was presented to the ethics committee of the University of Antioquia. The protocol involves also 3 different stages. The first stage is related with take the vital signs, electrocardiography, photoplethysmography, and non-invasive blood pressure during 5 minutes at rest. After that, we measure the signals, but asking to the volunteers to perform controlled movements in laboratory conditions, for example, using treadmills or ergometers. And the last stage is related to register the information 5 minutes to address again to compare the results between the movements, the vital signs before and after to perform movement. The equipment that we used to perform the measurement was developed in part in the master degree thesis and in this PhD thesis too. The equipment involves the measurement of the electrocardiography, photoplethysmography, and non-invasive blood pressure in 2 different points of the body. I mean, the electrocardiography is measured in the chest and in the back. The blood pressure is measured in the 2 arms, and the photoplethysmography is measured in the 2 wrists, also with the movement of those sensors. All those information is measured simultaneously and redundantly. Now, with this, I accomplished the task number 1. I will talk about the task number 2 that is related with characterization of motion artifacts. This task is part of the solution of the specific objective number 1. And after the solution of this, we obtain a paper in the computer methods program and in biomedicine journal. Let me present the brief description of the problem. The goal to obtain after this study is to change the physiological signal. The objective is to preserve the clinical information in the signal. The strategy that is common use in the state of the art is to maximize the signal to noise ratio. And the challenge is that when you introduce the denoising method, it's possible that you introduce distortion into the signal too. We make a state-of-the-art review where searching the main methods that is used to reduce the motion artifacts, and we found that all the methods are based in those 5 specific methods. One of them is the modulation spectral filtering. Other is wavelet shrinkage and empirical mode decomposition. And the combination of wavelets and empirical mode decomposition with independent component analysis. The performance measurement that is used in the state of the art does not consider the distortion introduced into the signal by the motion artifacts, by the noise, or by the denoising methods themselves. Then we propose a methodology that will compare the result of the denoising using those specific method that is proposed in the state of the art, and also propose a measurement of the performance that involves the measurement of the distortion introduced into the signal. After this study, we obtain a methodology that we call ensemble average ECG. The database used for this first study was composed for 24 epochs of 60 seconds of signals provided for a synthetic model. This is because is the methodology that is used in the state of the art. Test the denoising methods with a synthetic signal. But also we use 24 epochs from healthy volunteers and try to test the denoising methods with those signals. As I mentioned before, we obtain a methodology to evaluate the distortion introduced into the signal. We use the ensemble average ECG to measure this distortion. The method that we propose consists into determine the specific waveform that compose the signal. Let me show a laser pointer. This is the pattern wave that compose the ECG signal, for example, and determine a specific point that we call the fiducial point. In this case, we select the QRS peak. After that, we divide the long signal in the specific pattern waves and makes that the fiducial point overlapping between them, and obtain the average of these signals. With this, we can to evaluate some characteristics of the signal, for example, the amplitude, duration, and time of occurrence of the different waves into the signal, the P, the QRS complex, and the T wave. We evaluate the percentage difference between the signal acquired with the denoised signal with the methods, the signal contaminated with motion artifacts, and the signal acquired at rest of with the patient, with the volunteers. After we make the evaluation, we evaluate the signal to noise ratio as is proposed for the state of the art, and we found that in the case of the synthetic signal, the best result is obtained with the wavelet ICA method and the discrete wavelet transform. But in the case of the real signal, we obtain a different result. We obtain that the best method is obtained with the best result is obtained with the modulation spectrum filtering and the wavelet independent component analysis. Also, we perform the evaluation of the distortion introduced into the signal, evaluating the waveform of the signal, and found in the case of the synthetic signal that, and in the real signal too, that is not possible to obtain a good denoising of all the waves of the signal with just one method. We need to use different methods to obtain good results for a specific characteristic of the signal. I mean, in the case of the amplitude of the P wave, is good idea to use the wavelet ICA method in both cases, but for example, in the amplitude, the wave T, is better to use empirical mode decomposition in the case of the synthetic signals. Also, we evaluate the distortion introduced into the signal for the denoising methods, and we come to see that in the case of the synthetic signal, we obtain a very good results in the denoising with the denoising method, in the denoising process. We come to recover with a good approximation the P wave, the QRS complex, and the T wave too. But in the case of the real signals, the signal acquired from the volunteers, the results with the denoising method was not good. And look, in this case, I use the method that present the best result in the signal to noise ratio measurement. And we come to see that it's not possible to recover information about the P wave or the T complex, the T wave in the case of the denoising. As a specific conclusion of this part, we observe a general noise reduction in ECG signal using the signal to noise ratio assessment, but it doesn't not mean an improvement in the ECG signal. This just indicates a reduction in higher energy noise components in the contamination signal. Distortion introduction in the enhanced signal was detected through ensemble average ECG in the denoising process. It is in contrast with the result obtained with the signal to noise ratio. The use of just one denoising method does not guarantee to obtain the least distortion in all signal features. It is necessary to apply a specific method to analyze a specific feature into the signal. And the synthetic signal showed less distortion when compared to the ECG signal acquired from healthy volunteers. That means that it's not possible to evaluate the improvement of the denoising method just using a synthetic signal. It's necessary to evaluate the denoising method with the real signals too. With this, I accomplished the task number 2 and the objective number 1. Now, let me present you the task number 3 related with the model of the contamination effect of motion artifacts. The result of this task involves the solution for the objective number 2, and we obtain a paper published in Sensors journal. Okay, let me begin with a brief description of the problem. The goal in this part of the thesis is improve the quality of the physiological signal. The objective is preserve the clinical information. The strategy that is common used in some research is to change the sensor location in the monitoring, but the challenge is that changes in the location introduce distortion into the signal. As an evidence of this problem, we found that the professionals take special care in the location of the sensors. The person movement and the electrodes location cause artifact contamination and also cause misdiagnosis from 17% to 24% of the cases. Then it's necessary to follow the Indovent triangle or the Mason-like curve distribution in the use of the electrodes in the ECG recording. The problem with this is some wearable devices modify electrode location to reduce the physical size of the devices, also to increase the comfortability and to try to reduce the motion artifacts. But there is no real proof that this change in the location improve the signal. Then we propose a measurement of the location sensitivity and also the artifact sensitivity when we change the location of the electrodes in the body. After that, we obtain a computational model that allows us to evaluate the sensitivity of these changes. Then the database used in this part of the thesis was composed for 20 healthy male volunteers signals. The signal acquisition was made in the torso and in the back of the volunteer. We use a methodology where we put the reference electrodes in the location that is recommended for the Manson-like car method, and we acquire the signal modifying the position of the electrodes in the body, in the chest and in the back, in the points that I show in the figure. We acquire the signal, follow the same protocol that we proposed in the ethics committee, 5 minutes at rest, 5 minutes performing controlled movement, and 5 minutes at rest again. And we guarantee the synchronization and of the acquisition of the signal. We model the physiological behavior of the electric signal inside the body. For this model, we involve 2 different models. The first model is composed for a body model that involves the information of the tissues that are around the heart. For example, the lungs, the muscles, the blood, and the skin. And this model is solved with the solution of the Maxwell equations, but also we model the different parts of the heart as the source of the electrical signal inside the body. This model involves the solution of the different structures that compose the electrical conduction system of the heart, and is solved with the Hodgkin-Huxley equations. After the implementation of this model, we obtain a very good approximation of the behavior of the heart, the electrical activity of the heart inside the body. And when we put different points of test in the surface of the volume conductor, we obtain a very good shape of the ECG signal. That means that our result is near to the real approximation. With this model, we want to evaluate some ideas that we have about the development of this thesis. We test the signal acquired in the chest and in the back of the patient, of the volunteer, sorry, in the reference points, searching if there is possible to measure this information with a very good approximation. And we found with the computational model that the similarity between the signal acquired in the chest and in the back is near to 90%, and measure this similarity with the signal acquired from the volunteers, we obtain a similarity near to the 95%. Then with this, it's possible to conclude that it's possible to measure the signal in both places without a big difference. Also, we observe, evaluating the motion artifacts in the signal, that there is a very big difference between the signal acquired in the chest and in the back when the noise is introduced. Then give us the idea that it's possible to subtract the common information that is related with the ECG signal from this to this pyro signal. Also, we compare the similarity between the signal acquired in the reference position and in each of the modified positions. And we found that in the case of the signal acquired at rest, we compare the different positions that we made the signal with the reference position. And when we go far from the reference position, we acquire a very big different signal, very different signal from the reference signal. Then it informs us that it's not possible to move the position of the signal without without introducing distortion into the signal. But the other analysis that we did is the reduction of the motion effects into the measurement when we change the position of the signal, or the position of the sensors. And we found that don't matter when you locate the electrodes in the chest or in the back, the noise introduced into the signal has a very, very big influence and has no difference in the position 1 or 6. Or the difference is not considerable to make a modification in the position of the electrodes. Then, as a conclusion of this part of the thesis, is that the similarity between the signal of the same lead in the torso and in the back was 91%. According to this, it is possible to measure a lead of the ECG signal both in the torso or in the back. This result shows that only position 1 and in some cases position 2 can be able to take in an ECG without a bit distortion. And this model allows the fitting of the signal measurement in location other than the endovent triangle by giving information about the level of distortion introduced in the parameters used in the modeling of each independent segment of the ECG signal. With this, we finalize the task number 3 and accomplish the objective number 2. Now I will present the methodology and result followed in the task number 3, related with the evaluation of the modification in the hardware of acquisition. After this task is related with the solution of the specific objective number 3. And after this, we obtain an invention patent in Colombia. Let me present you a brief description of the problem. The goal in this part is to improve the performance of wearable monitors. The objective is to design a wearable vital signs monitor. The strategy that we use to design this is base our design on findings of previous studies. And the challenge is obtain a desired performance in wearable devices. As I mentioned, we base the design of our device in previous studies and development. We base our design in the patents that we found in the state of the art. But the problem with this is some wearable vital signs monitor were already proposed and patented in the state of the art. But these do not consider the motion artifacts contamination as a challenge. They just consider, in some of the case, the usability of the device or the good shape of the device, but not consider the motion artifacts contamination as a challenge. Then we propose a methodology of design based on the results obtained in the last part of the thesis, that is the use of redundant measurement and the multiple sensors to obtain the signals. And after that, we obtain a wearable vital signs monitor. I will remark that part of this development was beginning in the development of the master degree thesis, but some modification and better approximation are found with the development of this thesis. For example, the use of redundant measurement in the different sensors and the inclusion of the sensor to measure the movement of the relative movement of the sensors with the body. This is a photography of the first version of the monitor that we obtained, in which we just implement one of each sensor. I mean, one electrocardiography, one photoplethysmography, and one non-invasive blood pressure. And this is a photography of the improvement of the design in performance way, where we include the measurement of the ECG in the chest and in the back, the measurement of the pressure signal in the two arms, and the measure of the photoplethysmographic signal in the two wrists, also with the measurement of the relative movement of the sensors. With this device, we perform the measurement of the physiological signals of 24 healthy volunteers. The information obtained with this device has redundantly and simultaneous acquisition of the vital signs. And the results of the measurement of this device are compared with the pattern equipment that is used to calibrate a vital signs monitor in a commercial way, and also compared with the signal obtained with commercial devices. And the error obtained in the signals was less than 5%. Looking the result of this device, we are working now in the implementation on a very good design, proposing a better shape design. That for this is necessary to implement a better manufacturing process to produce the electrodes and the conductors to improve the design. As a conclusion of this part, we obtained that these kind of devices allow to improve the care methodologies and predictive models of attention that can improve the future health condition of the patient. And the implementation of redundant signal registration methodology allows to ensure the correct acquisition of desired vital signs information. With this, we'd accomplish the task number 4 and the objective number 3. Now I will present the result of the final task, the task number 5, that is related with the implementation of the multi-channel signal processing technique for motion artifacts reduction. In this case, for the ECG signal. This is part of the solution of the objective, the specific objective number 4. And we have a manuscript pending to publish because the result of this depends on the publication of the previous papers. Then, a brief description of this problem is the goal is to improve the ECG signal in wearable monitoring. The objective is to reduce the motion artifacts in ECG signal. The strategy is to use a redundant and simultaneous signal acquisition, and the challenge is to the noise method and the signal quality assessment index. The problem is the information provided for these devices has a lot of contamination. Then I will clarify the meaning of the redundant word because sometimes it's confusing. But in our case, redundant measurement refers to the acquisition of the information from the same interest source from 2 or more different measurement points. Then, after this, we use the redundant measurement and the multiple sensors to propose a method that we call redundant noise independent component analysis, or RDICA. The database that we use for this part of the thesis was composed for 20 healthy male volunteer signals. The signal acquisition was made in the torso and in the back of the patient, followed the Manson-like distribution. And the movement requested in this case was a maximum speed of 4.8 kilometers per hour. the protocol followed was the same that we proposed in the ethics committee endorsement. Then the scheme that we propose to reduce the motion artifacts in the ECG signal is presented in these slides. I will try to explain this in a better way. In a first stage, we can to obtain information about the ECG signal address of the patient. In some moments of the registration, it's possible to obtain ECG signal address of the patient. Then we made a characterization of this ECG signal, obtaining the different features, as for example, the amplitudes, duration of the time of occurrence of the different waves into the signal. This information allows us to model autoregressive model of the ECG signal that is our source of comparison. Then, when we obtain information contaminated with motion artifact, in this case, measurement made in the front and in the back of the torso, we use this information also with the information of the movement of the sensor as inputs or a independent component analysis method. This allows to separate the common information that in this case is the information of ECG signal from the independent sources that is in this case the motion artifacts. After this, we obtain a group of outputs that we compare with the autoregressive model of the signal that we hope. And after that, we obtain the output as the signal that we desire. This signal is denoised with wavelet Cray again to obtain a very good shape of the ECG and enhance the signal. Then to measure the performance of our method, we compare the performance using the wavelet Cray, only the wavelet Cray over the signal, or the wavelet independent component analysis method. As I will show you now, we perform this comparison, and using in this slide, I will show you that we use the similar contaminated signal for the 3 different methods. In the upper part, you can see the contaminated signal with motion artifacts, and you can see that it's not possible to identify characteristics of the signal, for example, the P wave or the T wave, and it's possible to interpret some parts of the signal as arrhythmias or something like that. When we apply wavelet Cray, we observe a shape improvement, but it's not enough to determine clinical information from this signal. In the case of the wavelet ICA, also obtain an improvement of the signal, but with a distortion in the characteristics of the signal. But in the case of our RD ACI method, we can see that we could obtain information about the P wave or the T wave in the signal and improve the baseline wander and other other noise remotion into the signal. We made a test of our method using different measurement indexes. For example, the signal to noise ratio that is common used, and we found that our method has the better signal to noise ratio improvement. Also, measurement the dynamic time warping that measure the difference between a problem signal and reference signal, and we compare the ECG signal acquired at rest with the denoised signal, and we found that our method obtained the less difference between them. And also evaluating the percentage difference between the characteristics, and we found also that our method present the best result. As a specific conclusion of this part, we can to say that the wavelet K and the wavelet ACI methods attempt to recover waveform of the signal, but introducing distortion. However, the RD-ACI method recovered largely the ECG signal waveform and shows a good reconstruction of an improvement of the ECG signal. Both signal-to-noise ratio and dynamic time warping indexes show the advantage of the RD-ACI proposing method to denoise the ECG signal over the results presented by wavelet K or wavelet ACI methods. These results show that the method to acquire the signal redundantly and simultaneously, which improve the result of the denoising of the ECG signal. Now I will present the multi-channel signal processing techniques for the motion artifact reduction for photoplethysmographic and non-invasive blood pressure. In this part, we have also a manuscript pending to publication. The database used in this part was the same database acquired for the last part, but in this case, we use the signal acquired from the non-invasive blood pressure signal or the PPG signal. The PPG scheme that we use is related also with the use of redundant measurement. We obtain the red signal and the infrared signal from the left and the right hands. We apply the ACI method, but we base our finding in the noised ECG signal that we obtained for the last method. With this, we obtain the position of the earth peaks. That is our base to synchronize the information with the PPG signal. This based in the premise that for every single ECG signal is produced just a one PPG waveform. That has a physiological context, but okay. After obtain the improved red and infrared signal, we use the saturation calculation to obtain the oxygen saturation of the blood with the noised signal. The oxygen saturation is based on a method proposed for Maximo, where use the red and infrared signal, but we include information about the motion that we acquire with the motion sensors. This produces a reference signal that is compared with the red signal through an adaptive filter. And with this, we can obtain the information of the oxygen saturation as the maximum energy of the comparison. In the case of the non-invasive blood pressure, we use the pressure and the oscillatory signals. This oscillatory signal is improving with a adaptive filter, and is compared with the movement scalar signal, with the movement signal. Then we perform also a synchronization assessment in which we evaluate that for every single ECG peak into the signal, we just obtain only one oscillation in the pressure signal. After this, we perform the evaluation of the systolic and diastolic pressures. As a result of the denoising of the PPG signal, we can observe that when we try to measure the oxygen saturation with contaminated signals, we observe a very big distortion into the signal, and it's not possible to obtain a good result of the oxygen saturation. But after we apply our method, we obtain also the distortion, but a very good shape in the signals that we acquire and is able to calculate a real ECG, a real oxygen saturation information. In the case of a non-invasive blood pressure signal, we compare the measurement of the pressure of the patient at rest, the signal with motion artifacts, and applying 3 different methods. In one case, field filters, wavelet shrinkage, and the method that we propose that is based on adaptive filters. And we found that our method presents a better approximation of the real signal, of the real information. As a conclusion of this part, we can to say that as evidence in the state of the art, the problem cannot be addressed only from software approximation. It is necessary to modify the acquisition hardware and implement software processing techniques to improve the quality of the signal. After the denoising of the signal, the conservation and recovery of the some main characteristics of the signals was observed. These characteristics of the signal waveform that had been masked by the motion artifacts allow to calculate the oxygen saturation and the non-invasive blood pressure measurements. With this, we accomplished the task number 5 and the objective number 4 of this thesis. Now I will present you the main conclusions, the future work, and the achievements obtained with this thesis. As my main conclusions, we found that this thesis presents an advance in the development of wearable monitoring devices. This is in accordance with the needs evidenced during the last year that promotes the self-care culture. As shown in this thesis, a new technique to reduce motion artifacts in photoplethysmographic, in physiological signals is proposed by the redundant and simultaneous measurement on the multi-channel signals of vital signs of interest. The third one is the use of sensor fusion and redundant measurement accompanied by multi-channel processing techniques and signal decomposition allow for a significant reduction of motion artifacts while helping to understand their nature and understand how they contaminate the signal from non-linear and unpredictable way. The fourth conclusion is there are a specific position in the chest and in the back of the person where signals obtain a high similarity, 95%. This allows a redundant acquisition system design for the acquisition of the signals in which differences in the motion artifact are evident and thus be able to separate these components in order to carry out the denoising. It was evident that a single signal method is not enough, but at the same time, it was shown that the method proposed in this thesis, based on the analysis of the characteristics of the signal, present considerable advantage. And the development of this thesis, physiological signal processing techniques for motion artifact reduction constitutes the basis for the development of research in personalized medicine. As a future work, in order to improve some of the weakness found in the methods proposed in this first study about the motion artifacts, it is essential to extend this work to a more rigorous analysis in the signals considering patients with cardiovascular and respiratory diseases. And a technological gap has been identified in the diagnostic utility that wearable vital signs monitor device might have due to the great influence by the person's movements have on the current measurement of the vital signs. For this reason, we will continue to work on the improvement of these techniques so that the results of this thesis enable this device for a clinical use with a higher level of confidence by reducing the risk to patients and improving the quality of life of them. as achievements, we can to highlight the 2 high impact factor articles that we obtained. One of them in Computer Methods and Programs in Biomedicine journal. That is a journal that is ranked in the Q1 rank, and the impact factor is 3.4. The other is was published on sensors, that is also in Q1 score. We obtained also a patent, an invention patent about our medical device. Also, we participate in different international conferences where we publish some works, and as a result of this, of the knowledge acquired of this thesis, we can to propose 2 different courses that are now in the bachelor degree of bioengineering and biomedical technology. Also, we have 2 more manuscripts pending to send into publication. And finally, I want to share with you these inspirational words from Isaac Newton. I do not know what I might appear to the world, but to myself, I seem to have been only like a boy playing on the seashore and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lie undiscovered before me. Thank you very much, and I will be glad to answer your question in English or in Spanish.
Thank you very much. We are beginning the presentation. That is given the opportunity to close the Q&A question, which may be as relevant as the student here with the thesis response. In order, is Professor Christian, do you want to begin?
Remote methods of patient surveillance.
Yes, thank you, Professor Christian. As I mentioned in the introduction part, the statistics that I show was found the year 2018, 2019. But this doesn't consider the impact of the COVID disease that is presenting now. We found that the necessity of this kind of devices has been increasing with this new crisis, because a lot of patients don't want to go to the hospital buildings, hospitalization buildings, because the risk to acquire this kind of illnesses. Before we begin this thesis, we found that the nosocomial diseases has a very high impact in the hospitalization statistics. I mean, near to the 20 or 25% of the people acquire nosocomial infections in the hospitalization rooms. And for this kind of problems, this type of methodology has begun to implement. But now with the new crisis, has been evident that the necessity of this kind of methodologies is very big. Then now we are working the development of this kind of devices to improve the quality of life of the person and reduce this type of risk.
Is it still me? Sorry.
Yes.
Okay. I thought it was some kind of rotation. Thank you very much. Perhaps you could give us an insight into the application within Colombia and your partners, and where this all might lead to, because I think it's very obvious the importance of that work, and how is the next step now in bringing your work actually to the people and applying your devices that you've shown in this presentation to the patient?
Yes. Okay. Our first stage, I think we need to increase the culture of the use of this kind of devices. That means no limitate the application of this device just for patients. I think is a good idea to begin with the implementation of this kind of devices in a general population. I know this thing is already in implementation with the use of smartwatch or other devices. For example, the people that makes sports, they use the different devices to measure their performance and the improvement of the health. But it's a good idea to make this type of devices cheaper and cheaper and cheaper, trying to implement the methodologies that we use not only for make cheaper and only two for ensure that information acquired is reliable to make a medical monitoring. Then I think the first step is bring this type of technology for a general population.
Very much. Just one last question. Looking at all these developments, I've noticed that conflict. When I looked at the validation study of atrial fibrillation detection of the Apple Watch, for example, it has all been validated and put into clinical trials for healthy people who have not been diagnosed with atrial fibrillation. And I see a conflict there that you perhaps choose or prefer to develop with healthy subjects rather than patient. Perhaps you can go into that too, and into the usefulness of your methods regarding patients or healthy people.
Yes, it's a weakness that I mentioned about my results. Usually it used to implement this type of methods first in the first stage in the healthy people, but it's because in my case, for example, I am trying to reduce the motion artifacts, but from this I hope to obtain a very good shape ECG signal that as the signal that we hope from the physiological studies. But if I include not also the motion artifact and also the modification in the way for the physiological problems, then I don't know I am really reducing the motion artifacts or if I am reducing the motion artifacts and the physiological information. But I come to remark that I don't show because was not part of my thesis, but I made some tests with information of volunteers with problem in the heart, for example, some arrhythmias or something like that, and I obtained very good results. I obtained that I reduce the motion artifacts and don't modify in a big proportion the information of his arrhythmia. Then I think my method has good perspectives, but needs more studies in this way.
Thank you very much. It's certainly no criticism. Even Apple is struggling, so great job. That's it from my perspective.
Thank you, Professor.
Thank you, Professor. Professor Robinson Alberto, it's your turn.
Okay. First of all, I would like to give congratulations to Fabian because you get a good job. At the beginning, the problem involved in this thesis is very difficult because it's a very big problem that many devices has, and many wearable devices lack of the confiability or the good results due the movement, the problems in the artifact motion. So the problem in that you that you face up in the thesis was very big. So congratulations for the results. You got to publish papers in very high top journals. Congratulations for the presentation. Presentation was very clear. Many doubts that I have when I read the manuscript, I was solved in the previous response that you sent to us and in the presentation. Just a little bit questions, not for because there is a big doubts about the results, but only for curiosity, for know how do you face up that problem. Okay, you can go to the slide number 20.
Yes,
please.
yes. Let me 1 second. I search the 20. This one.
Yeah. Here you go. Okay. When I read the manuscript, I was wondering about one specific point. In order to make a comparison between the signals that you acquire during the movement and you use a synthetic signal. Am I right?
Yes, yes.
Okay. My question is, how do you guarantee that it's possible to make a comparison between the synthetic signal, because the synthetic signal is almost a deterministic signal, it's almost, okay? And the signal that you acquire during the movement is a signal that has a very variability per se, because every second that passes in the test, the ECG signal is changing. but during the synthetic signal is almost like a phase signal is almost the same. And how do you say that it's possible to compare these two epochs that and because they are taken in different moments during the time?
Do you mean about the comparison between the synthetic and real signal? Yes.
Yeah.
No, I think I don't do the comparison between the two signals. I do the comparison between the synthetic signal with themselves. I mean, I simulate as ECG signal without contamination and ECG signal with contamination, and apply the denoising method in the signal with contamination and compare the result of this signal with the reference signal that is a signal simulated too, but without contamination. In the case of the real signal, I made the same. I asked for the volunteer to stay at rest. Then I acquired the signal without contamination, and making movement, I obtained the signal with contamination, applied the denoising method, and compared the result of this signal with the reference signal that is the signal without contamination. The way that I made the comparison and how I guarantee that the comparison is okay is because I separate with the ensemble average ECG, separate the different epochs or the different specific waveform of the signal, and make a normalization both in time and in voltage. Then we obtain, the same rule to compare the signal acquired with movement and without movement. That was a question that was made in the papers also, and I solved that, telling that yes, with this normalization in time, we obtain the strength or the dilatation of the signal, how we need to make the comparison. And I sent to them, I have not included this part on this presentation, sorry for that. But for example, I make the test of the signal acquired, for example, at rest 60 beats per minute, 70 beats per minute, 80 beats per minute, in different heart rate, and comparing that the characteristics of the signal are in the similar position. Not in the same, because as you mentioned, the dynamics of the ECG signal is very big, but at least in the similar position that we can do insurance that the comparison is okay.
Okay. I think that the method that you develop in this part of the thesis is amazing. So the ensemble average is ingenious, but I have that doubt, because you use this part of the signal like a template in order to compare the signals when you have a movement and when you have a risk signal. But the explanation that you gave us at this moment is very good. Okay, thank you for that. Okay. Okay, the next one is, you can go to the slide number 38, please.
38.
Mm-hmm.
The conclusions?
Yeah. Maybe the 37, please, in the results.
37, yes.
Okay, that's the point. When you evaluate that part of the thesis, the objective number 3, you got an error, a general error about less than 5%. Okay.
Yes.
Okay. But I'm wondering, how do you measure that general error?
Okay.
How do you conclude that the general error was less than? Yeah.
Yes, I prepared these tables to give a general vision about the measures that we do. We propose the measurement, for example, in the ECG, we propose the measurement of different heart rates, and with our this is simulated with a patching simulator, and the measures that we obtain with our device are in those ranks, and we apply standard deviation and error measurement of these signals. Also, in the measurement of the oxygen saturation, when the patient was at rest or the person was at rest, this measurement was at rest to compare the information between the signal acquired from our device and the signal acquired from a vital sign monitor. Then we obtain in general an error less than 5% in all the measures that we did.
Okay. Okay. It's a good result, because in this kind of devices, this magic number of 5% is always a goal. So
yes,
congratulations for that result. Okay. Okay, the next one is slide number 44. The next one.
The next one. This is 40. No. This one, sorry.
Yeah. Okay. In this slide, you present the results and the morphological shape of the signal in the third figure is wonderful. In the combination of these two methods, but in a quantitative way, how was the results that you obtained in this experiment, on these results?
Let me show you. We apply for this part also the ensemble average ECG methodology to measure this morphological result. The numbers I have not the info. Oh, sorry, I don't know what happened here. Are you listening me? Are you?
Yeah.
I lose my presentation. I don't know why. Okay, now. No, sorry. It's something bad with my computer.
Don't worry, take your time.
Are you looking my screen?
No, not yet.
Okay, let me share again. Now?
No, not yet. Now. Yeah.
It's okay.
Okay. I don't know what is happening. is something crashing my computer now. I don't understand. Sorry. I will try to share all my screen. Is okay now?
Yeah.
Okay. Then I perform the measurement of the ensemble average ECG of this signal. I didn't have the result numerically, the numerical result now here, but we acquired the information about the its standard deviation and the average of the signals. I will obtain that our method, the standard deviation are less than the obtained with the other methods. I have no the numbers in this presentation and in my mind also. Sorry for that, but in the figure you can to see that the distortion in general is less, and the standard deviation is also less in this shape.
Okay, don't worry. It's okay. I have two more general questions about the thesis, but it's most like a perspective of the project, maybe like an application and next step in the project. The first question is, in your system, you used a non-invasive method in order to acquire the pressure signals. But the method is the regular method that use the cuff, two cups, in order to obtain the dual signal for the blood pressure. But don't you think about use another method that avoid the use of the cuff, for example? Don't you think in the project at the beginning, or maybe you think, are you thinking about to improve the system using another method?
Yes, I found there is other methodologies to measure the blood pressure in the state of the art now. For example, now is useful the time transit method that compare the time between the air peak in the ECG signal and the pulse wave in the PPG signal. With this, is possible to determine the blood pressure in a I don't know, in a from calculation. Yes. Okay. But in the beginning of this thesis, that method that didn't prove that was a very good method. Prove that has a very good perspective to the future, but didn't have the good results. Now the method is proving that is very useful and had very good perspectives. I come to think that it's possible to implement now to improve the usability of our device. But when I begin the thesis, it's true that was no good idea to try with that, because then I need to solve not only the problem with the motion artifacts, but only the problem that validate this type of method. Then I think it was a very hard way. But now is a possibility that I will consider to improve the design of this device.
Okay. My last question is, okay, you obtain good results using all the implementing all the strategy for the thesis, and you validate the results offline. but one of the main purpose of the thesis is provide elements in order to improve the wearable device. So what do you consider is the next step in order to embed the solution, embed the methodology in a wearable device?
Yes, the next step is that make that these algorithms that I propose can to work in an embedded system. Make the text that if it's possible to implement this type of algorithms, this type of prediction that I perform offline. But I think it's possible taking the restriction that for this methodology I need to implement a lag of at least 10 seconds. I need to obtain a signal of 10 seconds to make the denoising of the signal. Then I really already consider the lags of my method, and I think it's not so bad since the information that I try to acquire is not in a critical cases. I think I can to admit and the community can to admit a lack of information or delaying the information of 10 seconds since the information is not to determine when you have a heart attack, for example, yes, but is the idea is for example, try to predict where you can to obtain that. Then the medical doctor that is using this information determine that the signal acquired are going bad. Then the next step is that doctor call his patient and ask him to go to the hospital for a more specialized analysis. Then it's possible to implement this methodology in like an online taking this restriction that I need and 10 seconds of signal to perform this measurement.
Okay. Finally, I want to insist in giving you congratulations for the thesis. I think that the problem that you faced up in this thesis was very big. It was relevant for the wearable devices. The problem is not easy. It's a really hard task to propose and validate the solutions in this topic. So congratulations, you need courage in order to face up this kind of problems. So congratulations for results, for the papers. For me, you prove that you are a leader in that topic. I hope that you continue with this work and proposing many results or many new knowledge about how to implement these kind of solutions in order that in a near future we can get better devices in order to acquire biomedical signals and provide solutions to personalized medicine or using this kind of wearable devices. So congratulations.
Thank you very much, Professor. Yes, and of course, as I mentioned in the last slide of my presentation, it is for me just the beginning. There is a very good way to go away in this line.
Thank you very much, Professor Robinson. Professor Rodrigo Gomez, it's your turn.
Hi, everybody. Congratulations, Fabian. It's not easy to evaluate this kind of thesis because we have published paper, there are patterns, and it's not easy. Thank you for your manuscript, for the presentation. The quality of the presentation is very good. And now I only have two comments or questions related with your presentation and your manuscript. When the slide 20, like drawing some talk about this kind of this slide.
This one.
Yes. You tell us you use, bueno, recommend use different methods for different this kind of synthetic ECG. I have a question. If you only need use one of these methods, which will use and why?
Ah, yes. I found. Let me go for other presentation, the other slides where I have this specific comment. Sorry. Where is this? Ah, here. Yes. No, here is this one. Yes. In average, the best result in the both cases was presented for the wavelet independent component analysis method. That method was the method that present the best result in those cases of the evaluation of the performance of the methods proposed in the state of the art.
Okay.
Yes, since this method don't present the best result, for example, for the cures duration, but present a low distortion also with this. The thing was it was not the best. It was a good method, but was not the best. But this method was had a very good result in this case.
Okay. The other things is related with the apply of this method. When I saw some kind of medical equipment, this I think they don't tell about this kind of method we use to this kind of problem, motion artifacts. I don't know how to say. Why do you think this kind of company don't how do you say, don't tell about this kind of which method we use to this kind of equipment? Do you understand?
A little bit. I think you are concerning about why the very big companies that produce medical technology don't use methodologies to reduce the motion artifacts.
No, I think they use, but they don't say what kind of method we use.
Ah, yes. I didn't find information about that. I think it's a very big secret in their development. Maybe because I can identify some things that they use. For example, in the oxygen saturation that you can to buy the cheaper one, they determine if there is motion artifacts, and after that they didn't make a measurement on the signal. They stopped the measurement and just present the the information that they acquire before the movement begins. Then I think some of the methodologies are going in that way. No obtaining information about the motion artifacts in the case that the device needs to be in a motion environment. But when the device is used in a controlled environment, for example, the hospitalization rooms, where you can to guarantee that the patient will be at rest, then they use other methodologies to improve the signal, but without compromise the waveform of the signal, without introducing distortion. That I think is happening in those cases.
What about the hardware? I don't know if the mix of this kind of techniques on mathematical methods and by instrumentation will be better, or I don't know, actually rate this kind of, to try to solve this kind of problem, motion artifacts.
Yes. I centered my searching in wearable devices, and I found a lot of proposals that they make, but it's based in the modification of the sensor. For example, some of them use a different instrumentation for the electric sensor that is applied in the chest of the patient. For example, introducing more specific amplifiers or capacity reductors to reduce the capacity effects of the motion effects. I found some of those, but I never found a methodology. The methodology that I proposed, that is the measure of the redundant signals. Maybe because this increased the cost of the devices, but I think it's necessary, because it's possible to determine the physiological source in a better way if you have this redundant measurement of the signal.
Okay, you think it's better use better hardware or focus on mathematical methods?
No, I think it's the best idea is to implement both. Make the modification in the hardware that you need to do to ensure that the signals has the good results, and also implement the mathematical and the filtering methods that you need to improve the signal. I am in the line that use the both signals, the both methodologies.
Okay. I don't have more comments. Congratulations again for your thesis.
Thank
you.
Thank you, Professor.
Okay, now we are beginning the jury deliberation stage of this defense. The members of the jury should cast their votes about the qualification of the research thesis. In the thesis if the thesis is approved, they should define, according to the requirements set forth in the graduate program's rules, whether or not there is any merit to award a special distinction. And now I have some later instructions. Professors Rodrigo, Robinson, and Christian, another link was sent to you for a discussion of this thesis evaluation. Please go to that link because it's another virtual room to this discussion. For the audience, we return to this link later. I will disconnect this link, but we return later to announce the thesis decision. And we are now stop the sound here, and I will pass with the jury to support the deliberation.
Okay, thank you, Anna.
Gracias. Nosotros, George, Fabián, toda la audiencia, no nos quedamos aquí.
Sí, muchas gracias por estar presentes.
Este es el momento en el que el jurado se retira y podemos hablar tranquilamente. Muy bien, Fabián. Muy bien.
Felicitaciones, Fabián.
Gracias a ustedes, profes.
Estuvo impecable. Todo muy bien.
¿Qué irá a decir Sarmiento? Sarmiento, diga algo, hermano.
Ah, no.
Me gustó mucho.
Of course, of course. Mauricio, Rodrigo no aparece en el enlace. ¿Tú le puedes decir que estamos en el otro enlace, por favor?
¿Tú se lo enviaste por dónde? ¿Por
A
correo?
él le llegó al correo a las
Ok.
direcciones que él tiene.
Listo, lo voy a recordar.
Por favor.
En las defensas acá, los directores también se retiran con los miembros del jurado.
No, aquí no. Aquí nosotros no tenemos ninguna injerencia. Digamos, no, eventualmente nos llaman a preguntar alguna cosa. Cuando no parece muy claro que el doctorando haya hecho solo su trabajo.
Increíble.
O cuando tienen dudas sobre determinado artículo que si fue aceptado, publicado, etc. No es habitual.
Lemos.
Acaba de llegar. Creo que acaba de llegar.
Buenos días, doctor Tumbo. ¿Cómo estás?
De más que estaba en otra reunión, simultáneamente.
Está en dos simultáneos.
Ajá.
Eso está más ocupado que tú, George. Eso es mucho decir. Sí, ¿no? Está en otra reunión.
Ajá.
Excelente. Excelente. ¿Y cómo le está tratando la situación por allá en Colombia?
Bien, pues.
Tenemos una variante delta que ya están diciendo, vamos a confinarlos de nuevo, pero ahorita es verano, no confinamos a nadie. Tiene ciudades en las que dicen la máscara es obligatoria, en las calles de la ciudad, pero en la playa de la ciudad no, ahí no hay máscara. Cosas increíbles.
Es que el virus, aquí el virus tampoco va a la playa.
A los bares.
Y a los bares.
Tampoco. Es algo que hay que preguntarle si en las discotecas es en las que la acostumbra a echar los bailes hasta altas horas de la noche, ¿hay virus o no hay virus?
Pues seguro que no, porque no lo han pegado. No debe parar.
Como en México.
No hay. ¿Y les hablan de una tercera dosis de vacuna o qué tipo de vacuna utilizaron allá principalmente?
No, aquí todas. A los de Vidic nos pusieron Pfizer porque entrábamos a la UCI y nos vacunaron de Pfizer. Muy afortunado. Pero aquí han puesto Sinovac, Janssen, AstraZeneca. La que toque, la gente se pone la que toque.
Pero Janssen es nueva, pues la pusieron hace poquito, ¿no?
Sí, van a poner la de toque.
De acuerdo, porque acá eso principalmente fue Pfizer, pero tenemos un movimiento de contestación fuerte sobre los antivacunas, porque decidieron ponerlo obligatorio para personas de salud y para otras personas, entonces automáticamente dijeron atentar a la libertad individual, etcétera, etcétera. Ahí vamos.
Tú te vacunaste, ¿no?
Todavía no.
¿Tú eres antivacuna? No,
No soy antivacuna. No soy
eres muy
antivacuna.
joven, eres muy joven.
No soy antivacuna, pero soy, ¿cómo se llama? Anti que me obliguen de hacerlo. a partir de un momento dijeron es obligatorio, y creo que voy a tomar tiempo. Entonces,
No, pero sí.
sí, obviamente que hay que ponerse, no queda de otra. Lo único que nos inquieta un poquito con la Pfizer actualmente, en los hospitales acá, los inmunodeprimidos ya tienen 3 dosis, y aparentemente les van a poner una 4. Eso quiere decir que más o menos por traslación a nosotros nos van a terminar poniendo 3. Y bueno, cuando no te la anuncian de una, es como que, ¿hasta cuánto nos van a poner? Entonces, pero sí, empezaron por vacunar ya seriamente. Pero hay 4ª posición por el concepto de que tengas obligatoriamente vacunado.
Claro.
¿Y los test PCR allá son pagos o gratis?
Hay las 2 opciones, ¿no?
Sí, si tienes prisa para un viaje o algo así, pues pagas. Si no, esperas no sé cuánto.
Ok. Ok, acá bueno, lo tienen gratis, pero por ejemplo cuando vas a Cataluña, en Cataluña es pago. Entonces los franceses que quieren ir para allá están que, bueno, ok, de regreso tengo que pagar 70 euros por un test, está como complicado. Entonces, y aquí es reembolsado por la seguridad social. Ahí se ha ido la cosa. Pero bueno, ahí vamos. Prevén un pico de epidemia para dentro de todo, para el enero de agosto.
Ana, de pronto tú me escuchas, Ana María, porque me dice Cristian que no ha podido entrar al link de liberación. No sé si Ana me escucha.
Espérate,
Sí.
se nos está cayendo mucho el profesor Cristian.
Sí,
Mucho.
eh,
Ya se unió.
ok. Bueno, cualquier cosa me dices, él me estaba escribiendo por aquí. No va a estar fácil la deliberación, Fabián.
Muy difícil, muy difícil.
Gran suspenso.
No, pero ya descansé del estrés y
Oigan, 52 minutos.
me pasé por 2, vea.
Imagínate. Estaba contando el tiempo.
Y eso.
Ahora le pasas el testigo a Sarmiento. Así que Sarmiento.
No,
¿Cuándo
cuando
defiendes
vaya
el
amigo, todavía no sé, depende de lo que coordinen en posgrado. Estoy esperando.
No, seguramente en agosto.
Pero Sarmiento era otro que estaba como en 2 horas en la presentación.
No, cuando me dijiste que eran 50 minutos, qué descanso. Esos 10 minutos valen oro. Que pensaba que eran 40 nomás.
Sí,
Demasiado poco.
40 de maestría.
Sí, a mí fue que me avisaron el lunes por la tarde, después de que hablamos, Mauricio.
Sí.
Me escribieron de posgrado diciendo que son 50 minutos y que el profesor Dios no había confirmado la asistencia a la presentación.
A ver, me invitan una invitación Google y yo, por favor. No, me envías un WhatsApp o algo diciendo, además tú me lo escribiste, yo te dije, claro que confirmo, no hay problema, no voy. Pero si me había pasado por uno, tenía que darle a una invitación automática que te llegaba por Google por posgrado. O sea, nunca te dije eso cuando me escribiste, yo que sí, yo ya te dije, yo confirmé. No, cuando entendí, pues entonces fue a buscar el mail automático ese y contesté, pero, o sea, pero bueno, así aprendo de cómo suceden las cosas y cómo pasan, cómo es el procedimiento en Colombia.
Sí, ahorita con...
La fecha, porque si es agosto yo puedo, aunque sea oírle la parte de la presentación, pues, con gusto.
Claro que sí, nosotros enviamos la invitación.
Eso, que yo sudé alguito, creo, en tu experimento.
Sí, lo has visto presentar ya varias veces.
No, pero George forma parte de la base de datos.
Ujú.
Creo que sí.
Sí, sí, de la
Bueno,
primera.
Sí, lo tuvimos que sacar pues porque está muy mal, pero él estuvo ahí.
Volvió.
No, pues imagínate cómo voy a ir ahorita. Bueno, aunque sí, quiero ir antes del fin de año. Ya estoy así como que me hace falta que Juan Diego me brinde un café. Estoy oyendo, Juan Diego.
Seguro, se escucha. Él se excusa es para no tener que hablar mucho aquí, pero está viendo una película en Zoom.
Probablemente. Probablemente, que tiene ahí está el Netflix prendido. Entonces, bueno, pero voy a ver si puedo cuadrar antes del fin de año, pero a ver, ustedes ya reabrieron fronteras, nosotros todavía están, decimos a veces en función de los países y todo lo demás, pero para América Latina normalmente se puede. Eso, que el virus ese no deja.
Yo creo que aquí la cosa está un poco más tranquila para entrar.
Lo
Creo que la
mismo si
restricción-
viene un país contaminado, porque aquí como hay un pico de prácticamente vamos a pasar los 20.000 diarios, imagino que los otros países que dicen ya va, él viene de un país donde hay 4 casos.
No, pero aquí cierran es cuando no hay mucho contagio y cuando hay bastante contagio abren y abren discotecas y todo. O sea, aquí en los picos es donde más apertura hemos tenido. Entonces,
Sí.
una lógica ahí rara. Y tapabocas, nosotros usábamos tapabocas N95 que nos los cambiábamos cada 3 horas cuando había un caso cada 2 millones. Así ha sido esto aquí. Entonces, no creo que tengas problema. Aquí el problema son las protestas, los transporte.
Cierto, las huelgas esas de estudiantes, porque los vi a ustedes en un video apoyando a los estudiantes de que estaban manifestando o algo así, pero no supe más en qué terminó eso.
No, aquí las protestas han continuado. Lo que pasa es que la estrategia con el paro es el desgaste. Entonces, esperar hasta que la gente se agote y diga, bueno, pues no más paro, sigamos. Bien.
Bueno, en todos países igual. Sí.
Y Fabián, está demorado eso, ¿no? Preocupación.
¿Qué será? ¿Qué será tanto lo que están?
Puro protocolo, Fabián, tranquilo.
Ajá.
Hermano, mientras no me llamen,
Todo bien.
todo tranquilo. Ahora, si llaman también a George, más complicado todavía.
Como me lo pongan por invitación Google, no llego nada.
Estabas poniendo a jugar con las diapositivas y bloqueaste el computador. ¿Qué es eso? No.
No, ya descubrí qué es. Me metí este cosito al bolsillo
Ay, Fabián.
y empecé a estripar botones ahí como loco y entonces eso era lo que enloqueció las diapositivas.
Ya le ibas a echar la culpa a él, pero ¿qué?
Claro, yo no, aquí, no, yo sabía que a Vicky, a la de sistemas de acá a la universidad.
A la IP 110.
Ajá.
Con eso hay una historia que siempre que pasaba algo con la red y Vicky se iba a buscar al laboratorio que donde se estaba generando esa IP.
Como nosotros éramos...
¿Quién era?
Siempre, no, nada, no era nada, siempre nos echaban la culpa y no teníamos la culpa de nada, pero ella nos culpaba. Entonces era muy curioso porque a veces llegaba yo al laboratorio y estaba ella allá y era como esculcando, como mirando, yo, Vicky, ¿qué necesitas? No, espérame que enseguida te digo, espérame que venía buscando a ver qué teníamos prendido.
Eso fue que Felipe se embolató un cable por ahí, se cogió.
¿Cierto? Se maté un pollito
aliviado.
para curar al enfermo.
tiempito.
Lo echan de la universidad. Sabían, está en la universidad, ¿cierto?
Ah, sí.
Y sigue en la universidad, me dijiste que no podía.
Ajá.
No, yo,
No, sí, sí se puede ir a los laboratorios, por temas de investigación y eso, pero es un permiso que no te imaginas. Se pide como una semana antes. Hay que tener, por ejemplo, las personas que no tienen contrato activo con la universidad, pues súper difícil. Bueno, no es sencillo en realidad, pero sí se puede, o sea, sí se puede. Sin embargo, yo, por ejemplo, estoy en la casa.
Pero no se puede tomar vino
ah, no.
en la universidad.
¿Solo cerveza o qué?
En Río Negro seguro que sí se puede.
Tiene un tarro de Coca-Cola o de Malta.
No, pero sí tenemos que citar para la celebración, eso sí, obligatorio, eso lo tiene que organizar Sara, menos mal que está ahí.
Felipe sabe que está grabando esta conversación.
Sí, no.
Me alegra, yo no tengo ningún problema con lo que estoy diciendo.
Felipe quiso que mete a la universidad.
No,
No.
la celebración por fuera de la universidad, Sara, ya que gracias por el recuerdo.
Lo de la cerveza en el vasito de Malta no es solamente para generar polémica, no es nada que ver con la realidad.
Cualquier parecido con la realidad es pura coincidencia.
Solo 5.
Yo pensé que íbamos a hacer un concurso del que tuviera la taza de café más grande porque George iba ganando.
No,
Ya se me acabó hace rato.
Sí, a mí se me acababa y George con esa taza.
¿Verdad?
Ahí, mira eso.
No, no es la taza grande, yo tengo los dedos chiquitos.
Que no parece.
No parece
No me
porque
envidia.
te sigue saliendo. Sí.
Ajá.
La taza mágica. Eso.
A ver, cuando yo le digo que yo necesito café para poder vivir, es en serio. Eso, alguno que haga una tesis con sangre verá que eso yo tener una dosis de cafeína en vez de al lado de hemoglobina.
Comparable las concentraciones.
Bro, ¿te da dolor de cabeza cuando no tomas, George, o qué?
No, por suerte no llevo hasta ese tópico, pero
A mí me pasa. Por ejemplo, antier me dio un dolorcito de cabeza como a medida y yo, ¿pero por qué? Claro, no tomé café. Cuando no tomo café, estoy tomando tanto café cuando me da dolor de cabeza. Leve, es leve, pero lo siento.
A mí me pasa igual. Nosotros hicimos una vez un quiz sobre cafeína, creo que María Bernarda estaba estudiando el pregrado, y tuvimos una base de datos y medíamos nivel de concentración en unos videojuegos que la gente no había experimentado antes. Bueno, no eran videojuegos, era una Nintendo DS con esas operaciones de matemáticas, y les dábamos el café en ayunas, hasta 3 expresos, y lo que ocurría era que la concentración se reducía. Y todo lo que pasaba la verdad, la respuesta en temas cardiovasculares, digamos en frecuencia cardíaca, hipertensión y todo eso, dependía más del acondicionamiento que tenía el sujeto. Sí, solo en personas que no tomaban café era brutal la respuesta, pero en los que ya estábamos acondicionados, bajaba la concentración a medida que pasaba más y más y más café. Era raro, pero interesante hacerlo en serio, pues, o sea, eso era como una exploración ahí con estudiantes y la gente que nunca ha tomado café sí se ponía con taquicardia, mareados, después del tercer expreso.
okay.
Es interesante, sí. Se puede hacer con tu monitor también.
Sí.
cuando atacan otra vez semestre? Ustedes están ahorita no de vacaciones, pero casi, ¿no? Deben haber evaluado algo así.
No, como estuvo lo de las protestas, se alargó el semestre como hasta septiembre, octubre.
De acuerdo. Entonces, ¿cuándo van a tener vacaciones o fin de semestre?
Pues vacaciones sí hubo a mitad de año, 2 semanas, y ya en diciembre el resto. Final de semestre sería en octubre.
En octubre.
Aunque arrancamos ahí mismo, me imagino. Hasta diciembre.
Ok.
Sí, pero con la dinámica de las protestas aquí, yo creo que este semestre solo hacemos un semestre. Pues, por ahí hay un lío con la universidad porque han estado en las protestas, la gente se va a hacer allá campus. Pues, eso bloquea muchas cosas.
Sí,
No sé,
y eso que la universidad está cerrada, que no hay ingreso.
exacto. No, y lo que pasa es que la actitud del gobierno con las protestas hace que eso no tenga una solución pronta.
Se envenena la situación.
Y como hay elecciones presidenciales el próximo año,
No es eso.
entonces, próximo año, pero las campañas ya están empezando. Entonces, claro.
¿En Francia están en alternancia o no están entrando a la universidad del todo?
A ver, acá hasta febrero, marzo hubo distanciación, después hubo un periodo en el que hubo nuevamente presencial, pero con porcentajes muy reducidos. Entonces, había eso, la modalidad de decir, bueno, se hace en 100% distancial, o sea, 100% Zoom, se hace en comodal, una parte de la clase está en presencial y una parte está en Zoom, pero la mayor parte del profesorado no aceptó ese tipo de modalidades. Entonces, se terminó separando las prácticas que eran críticas, o las clases que eran críticas, podían hacer presencial y las otras que tenían que ser 100% distancial y ponderadas para poder mantener un suficiente aireamiento y ese tipo de cosas en los edificios. Y así fue que se terminó el año. Teóricamente en septiembre empieza el año en presencial, solo que eso es la teoría, y como ahorita estamos subiendo fuertemente con el número de incidencias de casos y etcétera, pues capaz que el gobierno dice finalmente será en distancial. Pero lo que están haciendo ahorita es el pasaporte sanitario para obligar a la gente que se vacune. Es decir, usted no puede entrar a la oficina si no tiene el pasaporte sanitario, usted no puede ir al restaurante, no puede ir al cine si no tiene el pasaporte sanitario. Entonces, o te la pasas todo el tiempo haciendo test o te terminas vacunando. Entonces no sé honestamente cómo harán ahorita para septiembre. Hasta ahora no han dado consignas. En las vacaciones de abril dieron consignas el domingo para el lunes. O sea, tienes que adaptarte a eso todo.
Sí, bueno, que es
Lo que duele
complicado.
son los alumnos. Honestamente, el nivel de los alumnos, que claro, tú haces evaluaciones y tratas de adaptarlas con relación al material que has visto, pero en realidad no tienes la misma praxis. Si los estudiantes no han desmontado circuitos en electrónica, pues es complicado decir que ustedes saben hacer todo. Entonces terminas haciendo exámenes bastante modelados, cosas de esas, pero no se quedará dentro de 2 o 3 años en prácticas más serias o si volvemos a una situación más normal.
¿Cómo así? ¿Modelado es serio? ¿Cómo así? ¿Qué práctica más seria?
La práctica sería la del cautín. Eso no, olvídate. Puedes simular lo que quieras en MATLAB. Si no sabes soltar CM, ¿cómo se dice en castellano? La resistencia de superficie, la que no atraviesa.
SMD.
SMD, ok, en inglés. Entonces, si no sabes soldar SMD, el dispositivo no funciona.
Para eso tenemos a Angie, ¿sí o qué, Mauricio?
Claro.
Angie.
Sí, es una tecnóloga experta que ya suelda mejor que cualquiera.
Excelente. No creo conocerla, pero bueno.
No, para conocer. El otro día estaban haciendo un video ahí de televisión y entonces programaron, querían soldar, que Angie soldara unas componentes, entonces se acomodaron las luces, cámaras, todo. El camarógrafo dijo, listo. Y ella soldó ahí 2 resistencias de superficie rápido. El tipo dijo, bueno, suéldalas, ya acabé. Sí, bueno, el tipo le tocó revisar ahí porque 12 minutos.
Me parece, Volver está escribiendo que, o sea, Volver se salió sin que nadie lo echara, ¿cierto?
Parece.
Tenía ganas de escribirle, pero si no nos dijeron que nos saliéramos. Escribirle para que no se sienta mal, qué pecado.
Sí, no entiendo. ¿Qué pasó?
Mira, es que en el chat de Smart Bedin, Elber está preguntando que cuándo volvemos a entrar.
Ay, hombre. Dile que no, que ya que rechazaron la tesis.
Elber, siempre tan modesto, se sintió aludido cuando dieron evaluadores y se salió.
No, pero alguien que le diga que entre para que nos burlemos el práctico de él, no.
Ahí le dije que quería que entrara.
Vamos a hablar de que es una pena que esto haya pasado.
Eso.
¿Ah?
Injusticia.
Bueno, ya tenemos resultado. Entonces, voy a esperar que se conecten los 3 jurados y el profesor Rodrigo va a anunciar el resultado. Yo voy a dar enseguida el protocolo cuando los 3 ya estén acá. Profesor Christian, Profesor Robinson, and then Professor Rodrigo. Now, we are complete. Okay. Okay. Now we are inviting Professor Rodrigo Gómez Martinez, member of the jury, to announce their decision.
Hi, everybody. The decision was accepted the thesis. And we suggest a mention of magna cum laude for this thesis of Fabian. Congratulations again.
Congratulations, Fabian.
Thank you very much. Thank you.
Professor Mauricio, Professor Dortes, congratulations too.
Thank you very much. Thank you for the Professor Mauricio and George for the directing of this thesis. Thank you for the Professor Robinson, Christian, and Rodrigo for take your time to evaluate this thesis. And thank you everybody that support me in the development of this. I have no more words to spread the happy that I feel in this moment, but thank you so much.
Congratulations, Fabian. It's the highest possible grade.
Nice.
It's the best for you, and I agree with the judges about it because you did a really very good work. I feel really lucky to work with PhD students like Fabian because he's really an intelligent engineer. All time thinking the best solution. He has incredible capabilities to learn from other people. That is really important for scientific and academic work. I am sure he is one of the engineers who better understand the vital signs problems, the motion artifacts, and I think he will lead successfully teams to develop solutions in this field. Our thanks to George for his interest and helping this project, and also for his hospitality with Fabian during the stage in France. And finally, I really appreciate the help of Rodrigo, Robinson, and Christian for the time dedicated to analyze this thesis and this work. Robinson and Rodrigo for helping sequentially a lot of work from our university. We appreciate a lot your help. Thank you very much. And I sorry for long words, but I will congratulate also la familia de Fabián, la mamá de Fabián.
Ya se desconectó.
Bueno, tú le cuentas. Pero felicitar a la familia de Fabián y a los amigos, porque es un gran logro. Felicitaciones.
Muchas gracias a todos, muchas gracias. Thank you very much.
Thank you, Fabian, for these words. I would like to say some words too. It's very difficult. I think we should not forget that in a pandemic situation, very difficult to perform high-level research work. And thank to the judge, because thanks to them, we can be proud of these works. It's the best way possible. And specific work, I suppose, we will continue. And I will especially agree and help if possible for me to help with this work, because I think that we are in truth trying to perform this kind of mobile measurements. So especially thank you. It was very easy to work with you, with Mauricio, of course, and I hope that the collaboration will continue.
Okay, now at the end, the Indonesian School Administration Office would like to thank the judges for their presence and work. We further would like to thank the presence of all of the audience this morning. Thank you very much to all, and congratulations again. Bye-bye.
Bye-bye, thank you.
Bye.
Thank you.
Have a good day.
Profesor Rodrigo, no olvide enviarme los documentos. Muy bien. Bye-bye.
Bueno.
Bueno, felicitaciones, Fabián. Chao. Chao,
Chao, muchas gracias. Gracias.
A todos. Un placer haberles visto, aunque sea a distancia.
Hasta luego.
Todo.
Christian, thank you very much. I read your messages. Sorry about it, but the connection. But I believe you stay most of the time in the conference. Thank you very much.
Thank you, Professor Christian.
Chao, Ana, gracias.
Chao.
Espera que todos se retiren para yo poder